Okay, I just wanted to give you a quick little video on the standard normal curve, at least some maybe clarifications. I know we mentioned it in class a little bit, but um, let's talk about it here. So suppose we have a normal distribution. Okay, say heights, where the average is what, 70 inches, 5 feet 10. This is American men, 5 feet 10 inches, which is 70 inches, and the standard deviation is 4 inches. Okay, so I've got this, and we said mu is 70 and sigma is 4. And suppose I want to know what percentage of men are greater than 72 inches. So that's over here. Well, what if and then we said in order to do that, you find the z-score, which is 72 minus 70 over 4, which is 2 over 4, which is 1/2. Okay, so remember, the z-score is the distance, or the number of standard deviations from the mean. Okay, so what if I were to find the z-score for all of the points on here, like 71, 69, 68, 67, and so forth? I would get a z-score for all of these, right? That z-score is 0.5. 2 below is going to be negative 0.5. Well, what is the z-score at 70? How many standard deviations is 70 away from 70? 0. So that actually has a z-score of 0. Okay. Now, what happens out here at 74? What's the z-score there? It's 1, because it's 4 units above, so it's 1 standard deviation away. So let's take a look at this curve. These are my z-scores. So if z is 0, then that's going to be my center, or my average. And the standard deviation is 1, and I can put my z-score is 0.5, negative 0.5, 1, negative 1, definitely not to scale, and so forth. This is what we call the standard normal curve. So I have z-scores along the axis here, and since a z-score represents how many standard deviations away I am, a z-score of 1, that's 1 standard deviation away, right? Hence we get the 1 there. Okay, so it's our standard normal curve. So if I just said, what's the area? Well, let's go back to my original problem. The area to the right of 72, which is z-score of 1/2, that's the same as the area to the right of my z-score of 0.5 on this curve. Okay, so basically I'm standardizing every normal curve I can write to this, and this area, which is more than 1/2 standard deviation away from the mean, is the same as this area, which is more than 1/2 standard deviation away. So this is called the standard normal curve. Alright, hope that helps.